All right, hey everybody. Thank you so much for coming out. Hopefully you're in the right talk. I'm Robin Wood, and this is track 2. We're going to be talking about taking a break. And just kidding, this is track 1, you're in the right track. So I'm Dave Kennedy, and I really appreciate you coming out to the talk here. What we're going to be talking about today is the Antimalware Scan Interface, and I'll give a nice introduction around what AMSI is and how it integrates into different products. And most importantly, as an attacker, how can we circumvent AMSI in a way that allows us to gain code execution onto systems? And today I'll be releasing a new version of Unicorn that does the same stuff. So we got a lot to talk about in this 50-minute stint, and hopefully you'll learn something new. But first, before we start, let's give a round of applause for everybody that puts on Wild West Hacking Fest. This is incredible. Such a great conference, and folks that would actually travel out to South Dakota means that you're really part of this industry, and you really, really want to come to a security industry. Is anybody here close to South Dakota? Okay, we got a couple. Okay, so there's a few there. Is anybody have traveled more than 3 hours? Yeah, see, it's like it's most of us, right? Anybody have traveled more than 10 hours? That's some commitment right there. Yeah, that's some commitment. Adam, you live in the middle of like nowhere, so you can't even complain. Everything's 10 hours for you. It's in the country. No, I want to thank everybody out for coming out. Just a brief introduction myself. I'm Dave Kennedy. I started Trusted Sec and Binary Defense and another conference called DerbyCon with a bunch of friends. We just had DerbyCon a few weeks ago. Anybody attend DerbyCon? Awesome, great. Anybody have a bad experience? If you raise your hand, I'd like to talk to you afterwards. That's good. No one raised their hand. Also co-authored the book Metasploit, the Penetration Tester's Guide, helped out with, I wrote the Social Engineer Toolkit. I've gotten to help out with Mr. Robot, the TV show, testify in front of Congress, and on the news quite often and quite frequently. And funny enough, I was speaking in, it was at Chile a few months ago, and it was for ISC Squared. And I realized that all of the news interviews that I've been doing over the past few years, I was wearing the exact same suit and tie. And so I have one suit apparently that I only wear, and I have more suits, but I guess I navigate to this one. I didn't realize what I was doing, so that's another one, right there, and again, and even when I was heavier, like years ago, it's weird. I've also been in a rap video, which I thought was kind of interesting. I never thought that would happen. I'm more of a 90s grunge alternative person, but they wanted it was a rap video where they wanted me to hack into somebody's phone and delete all the videos of them. So it was like they'd broken up and they wanted to delete all the videos off of Facebook or pictures of them. So I thought it was kind of funny. But that's not why we're here today. And I made this very much Cobra Kai themed. If you haven't seen the new TV show, by the way, on YouTube TV, it's actually a really cool TV show, which is why I'm wearing this today. I thought it was pretty neat. And Johnny was actually getting bullied. Daniel was the bully, if you check it out. So it's kind of neat. There's a whole theory behind that at the moment. But today what we're going to be talking about is AMSI and the Antimalware Scan Interface. And I like to do these talks in a way where I show how to get around certain things or to circumvent certain things, but also from a defensive perspective, what can we do to get better? So it's going to be a blend of both. It's both a combination of attack and offense and defense and defending, because I think that's important in talks and presentations that we give. It's not all about doing something to get around something or to show a cool hack or exploit and then from there be super happy about it. But just some AMSI basics if you're not familiar. Some folks call it AMSI. I'm going to say AMSI because I think AMSI sounds weird. But it's the Antimalware Scan Interface, and it was introduced in Windows 10 and above, Server 2016 and above. And there's two primary functions with AMSI that are important to know. AMSI Scan Buffer and AMSI Scan String. And what you can do with AMSI is that you can send specific data to these functions to return to see whether or not it's malicious or not. Now, what's important with AMSI that I think is a very strong point is that it's basically at its rawest form. So things that have been obfuscated or things that are heavily encoded, you essentially get its raw form back and what it looks like. And I'll show some examples of this. And what's interesting about AMSI specifically is that it's open to a lot of different people. Like third-party applications can leverage this. It's not just Windows internals. PowerShell leverages this. Most recently, they incorporated it into scripting languages like VBScript and Office documents. So there's a lot of usage with AMSI currently. And so this is taken from Microsoft's site, but what we can see from a document perspective, what will happen is you'll have some sort of obfuscated macro, and then from there, if you go through AMSI, you'll essentially get the decoded form of what that's going to look like prior to execution. And there's some examples here from some good Microsoft posts around sharpshooter and deserialization attacks where you can leverage some heavy obfuscation in there, but at the end of the day, it does get put down into its rawest form, and you're able to see it. Now for some AMSI internals, what I like about this is that other applications can definitely roll into this, and Windows Defender makes definite use of this. So what will happen with things like PowerShell, for example, and we're going to show an example of this, is that we're going to use a heavily encoded PowerShell command using a tool that I wrote called Magic Unicorn. And Unicorn's a PowerShell exploitation framework that does obfuscation. And why that's important is that a lot of EDR products will look for things like encoded command or invoke expression or things like that, right? Now, the way that you get around those is by never calling invoke expression in its truest sense or encoded command right off the bat. If I went PowerShell -encoded command, that would probably raise some alarms from an EDR perspective or from a SOC analyst perspective to take a look at, because those are common attack avenues for PowerShell. But if you use something like toString or toValue in PowerShell, you can basically reassemble encoded command in a way that it doesn't get picked up by normal detection criteria. However, when you're integrating with AMSI, what will happen is you'll actually see the fullest, the rawest form of that, and you'll see everything decoded already. You'll see the encoded command being executed. You'll see all the code behind it, and it gives you a really good picture around what's actually happening out there. If you look at some of the statistics here, AMSI is currently supported, and this is from Lee, a great individual. If you're not following him on Twitter, I'd heavily recommend Lee over at Microsoft. He's one of the most fantastic people when it comes to PowerShell security, a good friend of mine, and somebody that is just an absolute massive brain of amazing. But if you see here from an integration perspective, there's still a lot of antivirus companies that haven't implemented AMSI yet or in the process of integrating that into their product line. Obviously, Windows Defender was one of the first, being a Microsoft product, and then from there, there's been additional support. And there's a lot of reasons for that. A lot of antivirus companies right now have their own decoders and parsers that they use. And that's actually problematic in a lot of cases. You look at what happened with Tavis, who found a bunch of 0 days in Symantec, where they had their decoder basically running in ring 0 in kernel mode, and just by sending an email, you compromise the entire system with system level permissions, right? And so there are some drawbacks to doing that type of model. So some organizations and antivirus companies aren't necessarily moving to AMSI because they have their own decoders or what they're using in a lot of cases, but there is a lot of pressure getting out there. Now, one thing to show is that Windows 10, from a population perspective, and this is from statcounter.com, Windows 10 makes up about 50% of the overall population in Windows right now. So 50% of the user population can support AMSI, and I think that's important to understand, is that you still have 50% that don't. So we have a lot of room to grow when it comes to AMSI support and what we actually have out there. Now, one thing I want to talk about, and this is directly from cloudblogs.microsoft.com. This is a blog that came out in August, August 27th. And one thing I want to take a look at is when I released Unicorn about 5 years ago or 4 years ago, I had two versions of Unicorn. I had one version of Unicorn that I never published, that I used internally for exploitation. It was more of a hack job type of version of Unicorn, where I had to use a 32-bit and 64-bit shellcode. It wasn't native. It didn't do the downgrade attacks or anything else. But I never published that version because it was more of an experimental version of it. There was a second version of Unicorn that I published, which is what is up there now today. Now, what's interesting is that every week there seems to be a new signature getting released for Unicorn. And I'll show an example of this today. And it is very much signature-driven today, regardless of what anybody else will say. It's very much signature-driven. We'll see examples of that here shortly. But interesting enough, the way that we're currently structured in security is we're working off of telemetry data or virus total, and we write signatures off of those in order to detect those specific things. But if you never publish that data, there's nothing out there that you have to worry about. So from 4 years ago, when I released my non-public version of Unicorn, guess how many detection criteria I have with that? 0, right? But the open source GitHub one that everybody goes and downloads, hey, they write signatures with every week. So right now in the current state of security, we're not looking at the behavior of things. We're very much looking at a pattern that we can use. Going back to Unicorn and specifically what we're looking at, a lot of things are being touted as machine learning. And really what we're seeing right now is big data analytics that bubble up code that might be malicious to analysts that then eventually write signatures for it. And a good example is, does anybody remember the Enigma 0x3 stuff that Matt wrote with a different type of extension type? I think it was content settings-ms. And anyways, this was a new extension type that was out there, and I thought it would be kind of funny to make a new extension type, and I called it APT28. And in the deep link section, I put a base64 encoded string, and I named a couple people, and I said, hey guys, hope you're doing well, love you, Dave. And then like literally within about 4 minutes of me uploading it to VirusTotal, I got direct messages saying, hey Dave, that was hilarious. Nice job uploading it to VirusTotal. So machine learning today is really large, copious amounts of data that people go through and then write signatures off of it. And while there might be specific patterns of behavior that you can leverage, like, hey, parent process of something calling a child process something else, in most cases, it's really focusing on very much signature detection. Now, interesting enough, with AMSI, most recent, this is a great blog post from Microsoft. You can see on the top here the encoded sharpshooter code that was being used on the top, and that's really difficult to, as an analyst, look through. But if I saw that, I'd probably say, hey, something's not right here, right? But if you look at the bottom of that, we can see pretty much in its rawest form prior to code execution what's actually going to be happening here. So we can see the dynamic evoke and the deserialization attack that's going to happen in memory directly through AMSI, which is, again, a much clearer picture for us in the security industry to be able to take a look at. Now, let's take a look at AMSI and PowerShell. So in PowerShell, AMSI, what's nice about it is that it'll if you're using any things like encoded command or different things, it'll actually get ready to execute and stage it with the interpreter, and you'll see basically its rawest form. And in certain cases, you'll see things like, hey, we detected PowerShell being used, it was suspicious behavior. And notice on the top that the behavior is Win32 Meterpreter Gen. Everybody familiar with Meterpreter, right? Metasploit Meterpreter. Interesting enough, in Meterpreter, it's shellcode that gets leveraged. It's got static bytes in there that can be leveraged for static signatures. So with Metasploit specifically, even if you're using something like Shikata or a lot of the other ones, there are bytes in there that are static as it goes along, and there's signatures that are written for that specific piece of shellcode. So there's ways of getting around that. So let's just take an example here. This is what it'll pretty much look like in AMSI once it's about to execute with the interpreter itself. And if you look here on the very top there, Windows Defender was flagging off of the bytes 0x33 and 0x1d being in the same spot. So what happens when we just create two new variable names and split up that shellcode? Gets around the Defender signatures, right? And so in this specific case, there's a lot of ways to kind of look it up, and I'm going to show you a demonstration here just in a few minutes around how you can quickly find what piece of the signature is being used in order to write around it. And it usually takes me about 3 to 7 minutes to write a different detection or a different way to get around those specific detection criteria out there. But in this specific case here, Unicorn, the way that it works is it uses create thread virtual alloc to allocate the resources in memory to the process and then inject shellcode directly into memory. In the very bottom there, you can see invoke expression. But notice on the certain thing on the very top here, there's little things that like they're flagging on kernel32.dll, but if you put like double quotes in there, it's no problem. You get around those specific areas. So one thing that I use to test is there's a great proof of concept here over at ek-nath. It was a GitHub page, and it's a Python script that you can run that integrates uses C types to integrate into AMSI, which you can call the two function calls, AMSI scan string and AMSI scan buffer. And I use this as a way to prototype a way to automatically submit my code, and I wrote an interpreted language in Python that recognizes PowerShell syntax that allows me to basically chunk up all of my PowerShell code in a way and submit it through that to allow to understand exactly where the specific pieces of code are being flagged within Windows Defender. Now, if we look here, before you start any demo, you always want to make sure that in the Defender settings that you don't automatically have automatic sample submissions. That's a bad thing if you're trying to get around antivirus, right? So turn those off first and foremost. And same thing for cloud delivered protection. You know, you can I think you can name that, but it has automatic sample submissions on that. So I turned both of those off so that I'm not automatically submitting my samples for telemetry data. And by the way, this is a big detection criteria for Microsoft. Automatic sampling of weird content or information is being automatically sent up to Microsoft for analysis for detection criteria. And that's a big way that they do a lot of their detection. So if you're trying to get around antivirus, don't upload it to VirusTotal like the Russians did, right? It's probably not a good example to say, hey, I can't get around antivirus, so upload it, try again, try again, try again. That's not the way you want it to be stealthy in a lot of cases. And then here you have the automatic sample submissions. So let's do a demonstration. So over here, I'm going to get out of this end screen here. Man, with Mojave, they got like this weird, so you can see it over there, but I can't even see it over here. Let me mirror display this real quick, 1 sec. All right. So over here we have a Windows 10 machine with its latest signatures on there. So let's just go to Windows Defender. We can go to Virus and Threat Protection. We can see here that the protection settings is up. It was updated on the 25th, which is today. If we go to the virus and protections, we have real-time protection on, and then obviously we turn off automatic sample submission and everything else that's out there. Now, if you use Unicorn currently today, which I'll be releasing a new version later today, this is unicorn.old. What I'm going to do is I'm going to generate a quick PowerShell script. And I'll just use Meterpreter. Now, in most cases, Meterpreter is a great solution, and with Framework 5, which is being released, they incorporated a new payload option which you can encrypt the payload into shellcode, which is nice. So there's actually an encrypt flag now in MSF Venom and MSF Payload that does a lot of better circumvention around the detection criteria on static shellcode. But in a lot of cases, if you're going around and doing an attack and you want to get around specific things, use your own shellcode or modify it in some way, shape, or form. Use your own stager. That's going to completely get around anything that you're currently focused on from a detection standpoint. So if you're using things out of the box like Metasploit or Meterpreter, you have a decent chance of it getting picked up. And you have to do some work to kind of play around with it. And I'm just going to use the reverse HTTPS. And I'm going to have it call back on my IP address on 443, okay? So it's going to generate the shellcode. Now what I'm going to show you first is I'm going to run the command itself, and then I'm going to decode it real quick just so we can see what AMSI would be looking at from an antivirus perspective. So if we take a look at this, notice here that this is my attack. Now if I saw this as an analyst, would you think that something would be wrong? Most likely, right? Now some funny things about EDR products. /W or -W1 and -C are commonly picked up by EDRs, but if you do a /W, a /C, it doesn't get picked up. Okay, and then notice here we're not actually calling encoded command in any way, shape, or form. We're using toString to convert encoded command down the road. So if your detection criteria is looking for encoded command, you're not going to see those. In addition, we also kind of chunk up a little bit of the code so that, let me find it real quick, so that the base 64 strings, if you're doing PowerShell as a language, that's a valid syntax, but in your EDR products that automatically try to decode a lot of those PowerShell base 64 encoded strings, it's not going to recognize that as a legitimate pattern. It's going to come out all messed up. So let's try to run this and see what happens. I'm going to take out the Windows 1 just so I can see the command being executed instead of closing the window down. And so we run this command, and this is from the command line, right? So we're simulating code execution on a system. We run this command, and no dice. We get this script contains malicious content and has been blocked by your antivirus software. So we're getting picked up by Windows Defender at this point, right? So let's take a look at what's actually happening behind the scenes under the hood. Let me just take a quick. Just going to convert the code to base 64 real quick, just so I can see the raw data. Just take me a second. So here's the code that's actually executing the backend that's getting picked up. Now if I highlight this, and I throw this in, oops, I probably should get better at quick keys. If I paste this into the PowerShell interpreter here in ISC, and I run this, notice it gets picked up by antivirus there. So that's a big deal. I think I didn't copy the whole line there, so one second. There we go. So if we're getting picked up by antivirus, what are ways that we can get around this? Well, I wrote this tool that looks just for, and you can do this by hand if you want to, but I wrote a tool called Prototype, and I can release the code, but it's very specific towards Unicorn. But it's going to take my PowerShell attack, and I need to regenerate it real quick. So let me just regenerate the code real quick. And then it's going to find and automatically submit to Windows Defender to find exactly where the signature's at. OK. So if I use Prototype, and I give it PowerShell attacks, and I go to mount, where my VM mount is at, it's going to start automatically submitting it in chunks with valid syntax. And it takes about 30 seconds or so to automatically go through. And it will try multiple combinations. So if there's multiple detection criteria, it'll find it. So notice here, it found a string match, 4, which is basically a while loop. So that's getting picked up. And we also have very specific opcodes that are being used inside of interpreter that are static that are being detected. So we needed to make 2 changes to Unicorn in order to get around AMSI detection with the defender signatures. So let's do a quick for. I think it's like that, right? And instead of for, let's just do while true, okay? So let me just do that real quick. And I can actually just do that in here. Let me just redo this again. And let me just get our new code in there. All right, we got our code with the while true, and we still got to take care of the problem of the opcodes as well. So let's paste this over here. And so the string that we were looking for is 0x8d, 0x5d, 0x68, and 0x6e, which are static opcodes within Metasploit. So let's find that real quick, and that's right here. So let's just chunk these up real quick as an example, and let's call this moo. I like cows. And let's just moo2, moo2. And let me make sure there's no, okay, there's a KB, so let's just do moo plus moo2. And all we're going to do is copy this in here, because all we did is just chunk up the shellcode, right? And did a while true. So let's get an interpreter listener going. And we get our listener going, so we're listening on 443 right now. And we're just going to go ahead and hit play. And I'm getting a syntax error, which is really weird. So let me fix that real quick. Let me just go back in and out here. It's not getting blocked, which is a good thing, but we're getting a syntax error. Let me just copy this in and paste it again. 1 second. Oh, I didn't remove the 4 for some reason. I didn't save the changes, that's why. So let's do while true. Okay. And then over here, let's give it a second. I'm getting an error for some reason. I'm not sure what I did. 1 second. Moo equals, moo2 equals. Well, that sucks. Hang on. I did practice this beforehand, but I do have a new version of Unicorn that has it all coded for me. So 1 second. So let's generate this again, and then it has the same changes in it. I'm just getting a syntax error for some reason, which I'm sure I did something wrong. And I'll just copy and paste this here. Actually, let's do it over here. It's slow. Son of a. Well, it does work, I promise. I must have did a syntax error in Unicorn as I was testing it earlier. But those are the 2 things that specifically it'll flag on. Now I want to show you another example here. And this is something that I built a while ago, and it's called Trevor C2. And this one doesn't get detected. I released Trevor C2 a year ago at Wild West Hacking Fest. And what's interesting with Trevor C2 is that it is a command and control infrastructure, and there's 3 different stagers. You have Python, which can be used for OS X and Linux, and if you have Python installed on Windows, I guess. It has a PowerShell stager, and it has a C# stager. And it's all open source and out there today. And the way that it works, from a detection standpoint, is really difficult to detect because it clones any website that you want to. So you can have it clone Google or anything else that you want. And it embeds the command and control infrastructure in an AES encrypted string that is spread throughout the entire HTML source of the website itself. So it's very difficult to reassemble those specific things out there and reassemble it back. Now what's interesting is I released that tool a year ago, and we still don't have any detections for it today. So you can still use it without any type of hindrance. So let's go ahead and run Trevor C2 server. And it'll automatically clone Google. Actually, I don't have internet connection, so 1 second. Ooh, which one do I join? I'll do my iPhone just in case. So once I join my iPhone, which will take a second, and then we'll clone Google. And it's not joining. Who's messing with the wireless? All right, there we go. So we'll clone Google, and we clone Google successfully. And what we're going to do is, this is the default code that is part of the stagers that's part of Trevor. And all you need to modify is the site URL of where it's going to clone the website to, and obviously use something with reputation. And I'd also recommend changing the cipher, the encryption key. The encryption key is obviously default and hard-coded into the GitLab zone. But again, we don't even have to change any of this at all in Microsoft or Windows Defender. So let's go ahead and run this. And then we run it. And over here, we get our connection. And we get our command and control infrastructure on a system without any detection whatsoever, released a year ago, hasn't been changed since a year ago, without any major problems or issues, through with AMSI and Defender loaded out there. So a lot of interesting pieces there, right? And very much signature-based driven, right? You're seeing where you have very specific opcodes that are being triggered that are more specific to Metasploit shellcode generating. If you use Cobalt Strike, no problem at all. If you use for loop and you change it to a while true, no problem at all, right? So it's a matter of understanding where the signatures are being written for those specific areas and getting that detection criteria to work. Now, there are some ways of if you're getting caught up by Windows Defender, there's certain things that you can do to disable either Windows Defender or AMSI in general. This is one that requires admin rights, and you can just do set MP preference and disable real-time monitoring to true, and disable OAV protection to true, which disables Windows Defender out there directly through PowerShell. One of my big favorite ones that was released back in 2016 was from Matt Graber, and this is using system management automation AMSI utils, and basically sets the value to false, which doesn't allow AMSI to scan what you're specifically going through, especially in your PowerShell function. And this does not require administrative level rights. Now, interesting enough, if you run this specific command here, we get picked up by antivirus, right? So antivirus says, hey, you can't use this. So is this technique actually burned? Well, no. If you just throw a bunch of single quotes and chunk up system management automation, AMSI utils, get field, AMSI failed, you throw a bunch of plus signs in there with single quotes, you have no problem executing that in the first place as well. So if you need to disable AMSI with the specific bypass technique, there you go. You can also, MDSec figured out a way, and it's really complicated, instead of a single quote, you put a double quote in there instead. So you take the single quotes, if you notice here, the single quotes are being used under system management automation. If you change that with double quotes, you get around the detection criteria, okay? Very tough. You can also use Matt's component here for COM server hijacking, which was fixed. It was released in 2017. It was fixed in the Microsoft Windows 10 build 16.232. Now, what's interesting with that, though, is that since this was an issue with AMSI.dll, you can basically just use an old version of AMSI.dll and still use this AMSI bypass. So if you just copy a code-signed version of the old AMSI.dll and put it in your same directory, it'll load that first to be able to get your specific technique to go through. So there's a lot of great stuff that you can still use with COM server hijacking as well. And so one specific thing is careful on marketing. AMSI shouldn't be touted as applied principles against machine learning when it's really signature-based detection with massive people writing signatures all the time, and that's what it is. I mean, if you look at every commit that has ever been done for a unicorn specific signature or update within Windows Defender, it has absolutely been a signature, not a specific behavior. And that's a big piece. I'm not trying to rip or make fun or do anything against an individual group or team, but if your whole concept is being able to take information that is being uploaded through VirusTotal or telemetry and write signatures off of it, you're losing the battle. You're absolutely losing what we're dealing with today. Instead of doing that, instead of looking at a specific signature, how about PowerShell injecting into its own process with shellcode? Is that a legitimate business process? Or do you normally see virtual alloc or create thread inside of PowerShell techniques? No. So those are things we can absolutely look at. AMSI does provide a lot of adoption and visibility into things, but again, the slow adoption that we're seeing with AV vendors still doesn't get you all the way there. And what's interesting is that AMSI integration into antivirus, all that means is that they're just doing better signatures. That is it. So again, if you use anything custom, use anything that is creative in some way, shape, or form, or just puts in a single quote or double quote instead of a single quote, you probably don't have any issues getting around the technology today that's out there. Just what's public. If you take Meterpreter and you export it, you use MSF Venom and you export it as an EXE, you deserve to be caught like that, right? But if you change it a little bit and use just the AES encryption that's in there or the RC4 encryption that they put in there, that's a different piece that probably gets around it, and test those out as you're going through. And so AMSI does give you some good visibility, but again, anything that is out there, and one thing I want to hit on is that when you're talking about SOC analysts and visibility, one of the biggest challenges that you have with SOC analysts is understanding whether or not it's malicious. Now, if you see something like Unicorn, something like this, if a SOC analyst sees this, does that look malicious? Probably, right? If you know what you're looking for in PowerShell, this probably looks malicious. Let me ask a question. If they see an invoke expression command being executed to Microsoft scripts.com/adprofiler.ps1, does that look malicious? No. So as an attacker, make your stuff look believable, and you don't even have to use obfuscation to go and do things. You can make things look in a way that are legitimate to the end user or to the SOC analyst that is going through the information to see whether or not it's malicious. It really messes people up when you make things actually look believable as you're doing it. If you're executing code like this, you probably have a good indication that something's wrong in your environment. However, use something like Trevor C2 and make it look like it's a polling application for data. Much different. And so detection today is pretty rough because blue teams, one thing we have going for us is more and more visibility. That's the big thing right now, is getting as much data back as possible to be able to identify edge cases. That's why things like hunt teaming has come out, right? You have threat hunters that go out and look for edge cases, go through all the PowerShell commands, they go through DNS logs, they go through all this data, and it's a big undertaking because there's so much data out there. And things like telemetry off of systems is especially useful, but it's only what is being submitted to those individual providers for that analysis. A good example is I wrote this tool in 2012. And this was building a native HTTP shell with AES and Python. And basically all it was a reverse shell that incorporates AES encryption over HTTP to communicate back and forth. And it's a binary that has no code signing abilities whatsoever, and it had 1.4 million downloads since I released it. So 1.4 million downloads, non-code signed executable binary, has a command and control infrastructure component in it, probably malicious, right? Especially in the environment. When I uploaded it to VirusTotal, only 6 out of 60 were even picking it up as potentially suspicious. That's our current state of detection today. Trevor, I talked about this before, 0 out of 60, at least a year ago. That's what we're doing today. Only if it bubbles up high enough into an environment do they write signatures or find specific things about it. There is no massive artificial intelligence combing through things and going through data to find out whether things are malicious. A human being has to determine that. And that's really what scares me right now in this industry, is that we use things like the MITRE ATT&CK framework. And I'm a huge fan of the MITRE ATT&CK framework of being able to go through simulations. But we use something like CertUtil, or we use something like RegSVR32. and we'll build a detection criteria off of living off the LAN binaries. RegSVR32 is a good example. So they'll look for /I with HTTP involved in it. What happens when you do /I with HTTP with a caret and a P in there? You get around the detection criteria. It's signature-based detection for command line auditing. And that's really what's concerning for me today, is that instead of focusing on the behavior of something, we're focusing very much on the pattern. And it hasn't changed since the 90s. It's the same boat that we're in today. Red teams don't really have to adopt much. We don't have to change our tactics much. It's really the same stuff today. Now, a good example of this is that instead of, for Unicorn, looking for invoke expression or a static signature in the shell code that somebody could use Cobalt Strike or their own personal shell code, why not look for PowerShell beaconing out to the internet in the first place? That's a good detection criteria. Are you going to have false positives? Absolutely. Especially Exchange. Exchange likes going out to Microsoft sites and downloading stuff for PowerShell and things like that. You're going to see variations and deviations of those specific commands out there, but at the same time, can you baseline those and say, hey, this is normal PowerShell code in our environment executing and going out to the internet, and look for deviations of those patterns of behavior? Yes. And what does that do for you? Now all of a sudden, it doesn't matter if they're using an invoke expression or coded command or a static specific signature for shell code, or if they're using a for loop or a while true loop or a kernel32.dll or something else. You're looking for the pattern of behavior that is occurring there and using that to bubble up to your analysts. And so we still today, to this day, regardless if they tout, we have a 99.5 prevention rate on exploits and malware. We have 100% exploit rate detection. We have, it's hogwash. It's signature-based detection on what we're seeing today. And you look at code execution today, and this is just what we see from a binary defense perspective, binary droppers still equate to about 84%. That's still your largest saturation of stuff. People are dropping executables all over the place, and we're doing nothing to stop a lot of those uncode-signed binaries that are going out there and dropping code. PowerShell is about 13%, and application control bypasses, or LOLBAS, which is binaries and scripts, are the lowest prevalence of that. And most companies are still focused on executables and maybe some PowerShell that they're getting out there. And I love things that are out there, like script block logging is absolutely fantastic. PowerShell version 5 and 6 is absolutely fantastic. Some of the best programming languages and secure programming languages out there, especially with constrained language mode and everything else that you're doing out there. But most people don't even put script block logging in place because of why? Anybody know why most people don't do script block logging? The Splunk licenses that you have to then deal with, right? The amount of logging that is coming out of those and the ability to actually go through and do those. I would say that I've only seen script block logging applied to maybe 5% of the companies that are out there today. And that's a problem from a visibility standpoint. If you're not familiar with what living off the LAN binaries and scripts are, these are legitimate binaries and scripts that are code signed by Microsoft that have code execution functionality. And why that's important to understand is that if you've done something like application whitelisting, right? Because I think application whitelisting is a solid practice, especially in high integrity mode with much less exceptions that you put in place. What you can do is there's a lot of binaries in Windows that have code execution functionality. RegSVR32, CBD.exe, CSC.exe, MSBuild, MSHTA. There's a number of them. There's 68 total currently for just executables. And there's a whole bunch for scripts that are code signed. These are code signed by Windows binaries. It's code signed by Microsoft that allow code execution functionality. And why that's important is you can have something like MSHTA. I love this meme, by the way. It's like the best one ever. My favorite. I put it in like every slide, every presentation I do. But here you can see like certutil with URL cache and can go out and download PowerShell code and have it execute. Certutil, import and export certificates, you still have the ability to download and execute code. WMIC, ability to go down and download XSLs and directly execute. RegSVR32 has its own built-in proxy and is proxy aware to go out and download code. These are binaries that have code execution functionality directly into Windows that give you the functionality to be able to attack it. So a lot of good stuff happening on the research side of this, and Casey Smith and Subt and Odvar Mo and a lot of folks out there are doing some great research around these different areas to get code execution through this functionality that pretty much escapes anything that we're seeing out there today. So for red teams, the good news is both from a detective and a preventative method, if you're using anything custom, you usually don't have any issue whatsoever getting around what is happening out there today, unless you have a hunt team that's really good and looking for these specific areas. And so that's a good thing for the red team. Telemetry data is one of our biggest concerns, right? Because as we go and we execute something on a system, if it bubbles up high enough, now you have people writing signatures for your code. And that's the biggest area. And a lot of these cloud providers and these third-party software companies don't have the ability to shut off things like logging. So it automatically sends the data back to these third-party companies or Microsoft or whomever, and they have the ability to write signatures off of your detection criteria. So when you're building your attacks, you want to do it from a perspective of it's very, the framework that you're using should be very easy for you to manipulate and change in the event that it goes and does it. Unicorn's been out for 4 years, and every week there's a new detection criteria that gets written for it, and every week there's a new Git push that comes out that gets around it. And so when you look at that, it's a never-ending battle when it comes to trying to go back and forth with these specific things. And as a simulated attacker, we need to focus on what the attacks that we're doing and the frameworks that we're using to go and do it. Like for example, let's look at an organization and say, well, hey, we maybe have a high probability with PowerShell as an attack avenue because of the visibility that they have out there. So let's use another method for code execution. Deserialization attacks are fantastic. Just don't use dynamic invoke. So just use a lot of different other methods that are out there. Blue teams, though, there are some good stuff. I totally be red and blue. AMSI in general does provide a great layer of detection. If you can take that code from AMSI and get it back to your SOC analyst to do analysis of, it's fantastic. It's great visibility and an abstraction layer that takes away a lot of obfuscation that's out there. And it's already built into a lot of the products out there that you have. With PowerShell version 5 and version 6, you have some amazing logging and detection with script block logging as well. Relying off of Windows Defender, though, as your main prevention method might not necessarily be the best way. It's a great product, but from a signature standpoint, it's just really not there. Tools claim, next slide. I'm a big fan of Sysmon. If you're not familiar with Sysmon, it's a free tool from Microsoft. It exposes what's called event tracing for Windows, or ETW. Massive fan of that from a detection standpoint and getting your information off of that and sent out to your central environment to be able to do analysis. Antivirus vendors, again, are still in the progress of doing AMSI integration. But again, even with AMSI there, it's still going to be one-to-one signature analysis for a lot of those pieces there. And any company, and again, this is my biggest pet peeve in the security industry right now, is that the marketing here is running wild with what's actually happening. And if you have companies that are touting machine learning or artificial intelligence, then maybe there are components of that. They're taking big data sets and they're automatically able to apply data to that to say, hey, this has a high probability of being detected. But I can tell you, tools claiming to do 99.5% malware block rates, 100% exploit detection, and 0% false positives is absolute hogwash. It's absolutely marketing, has absolutely no relevance in the security industry, and I can guarantee that because I test those products. And they're still very much signature-based. Guess what? They detect 100% on what they look for exploit detection. If you modify and change those in some way, shape, or form, again, signature-based detection, you have no problems getting around any of those tools out there. So just in general, in closing, and I'll be happy to open up to questions, is that from an AMSI perspective, there's a lot of techniques to circumvent and get around it. They don't even have to worry about obfuscation. So leveraging what's already built in and the research that has already been done is one method of getting around AMSI. The second is just modifying your code in some way, shape, or form to obfuscate it and test it in an environment that allows you to get around that. For blue teamers, having that information, though, is absolutely relevant and very beneficial for you. And something that I think you should be doing and getting into, but there's still a lot of work to be done in this industry. We're trying to get better at detection, and really we're relying off of a lot of big data coming into virus total and telemetry data to write our signatures from. That is not a maintainable state in this industry at all. There's no way that that's going to scale. There's no way that that's going to get better. We have to look at other methods. Anybody have any questions? No, the question was, is it possible to overwrite specific portions of memory when you're doing like AMSI scan string or AMSI scan buffer? Is it possible to overwrite that? And technically, yes, if you're doing an import directly into there, but the problem is that as it's getting submitted, it requires administrative level rights to go and do that. So if you're running in user land, not necessarily going to work in that specific case. So good question. Yep. Yes. Yeah, I got it. So the .NET assemblies, there's system.management.automation.dll and system.management_na.dll, and a few other DLLs that actually make up PowerShell, right? And one of the biggest bypasses out there today for PowerShell detection, especially in EDR tools, is by importing those DLLs, you can still run PowerShell without any detection because you're just calling the DLLs. You're not actually calling PowerShell.exe. Funny trick, if you have an EDR product, why don't just copy PowerShell.exe and rename it to like moo.exe and see what detection criteria you get off of that. It's kind of fascinating. But if you just import those two DLLs, and there's a tool out there called MPS Payload, which is written by one of our guys at Trusted Tech, two guys, Ben 10 and Larry Spawn. and basically imports those two using MS build and then does PowerShell execution through that. The question is does something like AMSI have the ability to still see that? And the answer is yes. You'd still see the decoded native states within that, even by importing system management automation. And same thing for script block logging if you have that enabled. As it's being passed by the Python interpreter, you absolutely see those logs and something you're absolutely able to see from that time. So I'm getting the 5-minute warning. So I appreciate everybody coming out. Thank you very much, and I hope you learned something new. Thank you.